Hello students, welcome to the class of sound and wave. After the discussion of phase, what I would like to say that we have to discuss the equation of plane progressive harmonic wave. Now in the discussion of wave, I have discussed, basically we are talking about mechanical wave. So in mechanical wave you have seen that transverse wave is there and longitudinal wave is there. For mechanical wave, as you already know, medium is required, and the medium should have certain property like elasticity. Medium should have the elasticity. Second, density. Medium should have the elasticity, density, and the property of low damping. This is our assumptions that we have to keep in mind in order to understand the mechanical wave. Now, transverse wave is possible in your solid medium and surface of liquid, whereas longitudinal wave is possible in all the three medium. This thing should be clearly understood in you. Second thing that I would like to give you as a reminder that we have derived the formula V is equals to F lambda. That means V is the wave velocity, which is the product of frequency and wavelength. Here what is important to understand that frequency F is the characteristic of source. So it is source dependent. It depends upon source. Whatever is the frequency of source, that is the frequency of wave. And V, velocity of wave, this is medium dependent. It depends upon the properties of medium. Whereas your lambda, that is the wavelength. This thing is very important for getting the hidden message of wave. Hidden understanding of wave will be clear to you if you understand this fact in a very careful way, that lambda depends both on medium and source. This thing should be clearly understood in your mind. Now I have discussed the phase concept in the previous lecture, and here I have to derive the equation of plane progressive harmonic wave. I am using plane progressive harmonic wave because here in this case the source which will generate the wave, that source will be performing simple harmonic motion. That means here the source will perform simple harmonic motion. You will also understand that how the concept of phase will be used here, that I have discussed earlier. So this thing should be clearly understood in your mind, that in the plane progressive harmonic wave, what is there? It is the source that is performing the simple harmonic motion. Source is performing the simple harmonic motion, and with this source the string is attached, so the wave will be generated on the string. With the source is performing here the simple harmonic motion and string is attached, so string is doing, the wave is generated. We also keep this thing in mind, as I told you, that here two considerations we will keep in mind. Two assumptions are there. Here assumptions are there to simplify the situation. What are those assumptions? Those assumptions are there. First, wave velocity remains constant. Wave velocity does not changes with time. And second is there, shape of pulse does not changes with time. Shape of pulse does not change with time. Keeping this much amount of background in your mind, we will try to discuss and we will try to derive the equation for plane progressive harmonic wave. So this thing has to be kept into mind. With this background, we will describe. Now see carefully. Suppose here is a spring mass system. Here is a spring mass system and a string is attached with it. and this is your mean position, and this spring is disturbed and it is performing the SHM from this region to this region. It is performing the SHM from this region to this region. So if the string is attached with it, this string is going to here, this is the mean position, and here we consider x is equals to 0, and the wave is going in this direction with the velocity v. It is plus a, it is minus a, so this distance is plus a and this distance is minus a. This source is doing the simple harmonic motion in this way, and there is a spring mass system. Here, as this source is doing the simple harmonic motion, this body is performing the simple harmonic motion. So we have the equation, if we consider that it is starting from the mean position, we have the consideration, the equation of this particle that is performing simple harmonic motion is given by y is equals to a sine omega t plus phi naught. If some initial phase is there, that means it is not starting. Or better you say y is equals to a sine omega t, where symbol have their usual meaning, one variable, which is the y is the function of time. With time, the y is changing from plus a to minus a. A is what? A is the maximum value of y, displacement of particle. Y is the displacement of particle. Now we have to derive the equation of wave. So equation of wave, you understand that if with time I am saying with time the y is changing, but y is also changing with the position x. Suppose here we are taking one value of x, here we are taking some different value of x. So at every distance, this is along x-axis, at every point, for every point the value of x is different. Here the value of x is different, here the value of x is different, here the value of x is different, and the motion of this particle is being transferred to other particles performing the simple harmonic motion. What is the difference between this particle motion and the particle which is here at point P at a distance x? What is the difference? What is happening here that will be repeated by this particle but after certain time. And if v is the wave velocity, see, particle velocity is different and wave velocity is different. If v is the wave velocity, then in reaching the wave from here to here, the time taken will be your x by v. X by v is the time. That means disturbance will reach here after time x by v. So what I mean to say here, if you want to find the displacement of this particle, this displacement you find here, which is basically the displacement of this particle earlier. What is happening with this that has already happened with this particle, and what is happening with this that will be happening with every particle in the wave motion. The same thing is repeated every time it is being transferred. It is being transferred to the other particles like that only. So first it will perform simple harmonic motion, then other particle will do, then other particle. So what I mean to say here, that here the equation is of this particle which is at origin. The particle which is at origin, x is equals to 0, is simple harmonic motion, y is equals to a sin omega t. And if I want the displacement of this particle, shape of pulse is not changing. If I want the displacement of this particle, so you should understand one thing. I want y of the particle at x and time t. I want the displacement of the particle at a distance x at time t. I want the displacement. This should be, we cannot find this displacement. As this displacement is repeated by, is the photocopy of this displacement. So I will ask with this particle. Try to understand. So this is the same thing. If I want this, then this is the same thing y. Of which particle? This particle. At x is equals to 0. And time is what? What is happening with here at t? This has already happened here at the time t minus x by v. So it is happening here at 5 seconds. And suppose if it is happening here at t second, here it has already happened at t minus x by v, because x by v is the time taken by the wave to reach from here to here. So this can be written as t minus x by v. See, this y I want and this y is known to we people. So they are equal. So in order to find the displacement of this particle, we talk with this particle. That what is its displacement at time t minus x by v. So in this equation, we will keep this value and we will get the equation of wave y is equals to a sine omega t minus x by v. Why? Now this is the displacement of which particle? This is the displacement of this particle which we are knowing by this particle. So actually this is the displacement of this particle and its motion is repeated by this particle. So this is the displacement of this particle also. So we are getting y is equals to a sine omega t minus x by v. And this t minus x by v is basically the equation. This is basically the equation of wave. And you have understood that here y is the function of x comma t. That means y is dependent on x also, position also. If you change the value of x, the value of y will be different. If you change the value of t, the value of y will be different. So this is the equation of wave. That what is happening with it at t, the same thing is happening with this at the time t minus x by v. So only one thing you have to do, if wave velocity is known to you, you will replace this quantity t by t minus x by v and you will be getting the wave equation. This should be clearly understood in your mind. Why I am telling this thing? Because what is happening with it, with this particle, the same thing is being repeated by the other particles also. So we don't have the idea of other particles, but as other particles motion is related with this, so any other particles displacement if I want, I will come to this particle at the time, if here it is t, here it should be t minus x by v. So we are able to find the displacement of this particle with the help of this particle. Basically its equation is known to we people. Here it is the equation of this particle. This is your source particle. Source. This is your source which is performing simple harmonic motion by this relation. This should be clearly understood by you people, that y is the displacement of this particle. But how we have got this particle? This particle displacement is basically this particle displacement. That means the particle at origin displacement at time t minus x by v. Why? What is happening here at t, that is happening here at the time t minus x by v. So what is happening at x and t, the same thing is happening at the particle at origin, that is the source particle, at x is equals to 0 and t minus x by v. So we have come in the reverse direction. And if we will go into the forward direction, if the wave velocity is changing, at the place of t minus x by v, we will keep t plus x by v. If the direction of wave is changed in this way, then we will replace t by t plus x by v. So right now you should understand that this is the equation of wave which is moving along positive x direction, and the source particle is doing simple harmonic motion. So this is your equation of plane progressive harmonic wave. So we have got the equation y is equals to A sine omega t minus x by v as the equation of plane progressive harmonic wave. What is y? Y is the displacement of particle. Maximum value is A, which we called as amplitude, omega angular frequency, t time, and x is the distance along x-axis, and v is the wave velocity. You should understand v represents wave velocity. Wave velocity. And we have considered that wave velocity is constant. Now I would like to give you some other formats of this equation, that if I say y is equals to A sine, this can also be written by taking omega inside. So this is giving you so you should understand it very carefully that here k, omega by v is your k, and it has got the name propagation constant, and omega is 2 pi by t, t is the time period, and t into v is wavelength, so 2 pi by lambda, that should be your wavelength, and that should be your propagation constant. So sometime we will be using propagation constant in this form, sometime we shall be using propagation constant in this form. So this is the standard equation of wave, and this wave is moving along positive x direction. Here negative sign is there, it is moving along positive x direction. If it is moving along negative x direction, then we can write A sine omega t plus kx. This will be moving. This is the equation of wave moving towards negative x direction, and this is the equation of wave moving towards positive x direction. If the particle has not started its motion from mean position at x is equals to 0, we can add additional phase also. So in general, the equation can be written as y is equals to A sine omega t minus kx plus phi naught. What is this phi naught? This is your initial phase. As I have told you in the discussion of phase, that what is the meaning of initial phase. So this thing should be clearly understood in your mind. Now here I would like to discuss with you that here you see y is equals to A sine omega t minus kx. Now let's talk about some unit and dimension portion. What should be the unit of y? That should be the unit of A. Why? Because this is dimensionless quantity. So what should be, if y is in meter, A should be also in meter. What I mean to say, this is the main thing. Second thing is there, this quantity should be dimensionless. So if the dimension of t we are taking second, then omega should be 1 by second. Why omega should be 1 by second? Because second and 1 by second will cancel and it will become dimensionless. If x, which is the position distance, if x is in centimeter or meter or whatever is the unit of length, then unit of k will be 1 by centimeter. Or if it is meter, it should be 1 by meter, like that only. So that this term becomes dimensionless. This thing should be clearly understood in you people. Now I will show you few equations, that how can we write the equations of various plane progressive harmonic wave if the source particle motion, simple harmonic motion is given. So let us try to understand with examples the clarity of concept of this term, that is equation of wave. Y standard format is y is equals to A sine omega t minus kx. And what should you remember? You should remember y is the displacement of particle, A is the amplitude, sine omega t minus kx, k is the propagation constant together with the unit, and also you should keep in mind that this wave is moving in positive x direction with the velocity v, where v is basically omega by k. K is omega by v, so v is basically omega by k. This thing you should keep in mind. Then we will discuss few examples for further clarifying the same concept. Let us take an example. Suppose we are taking an example. Here is the source particle. The wave is moving with velocity v, and this source particle plus a to minus a. This source particle is performing the simple harmonic motion, and its equation is y is equals to a sine omega t plus phi. Suppose this is the equation of this source particle that is performing simple harmonic motion. Here this is the mean position, x is equals to 0. On this axis x is there, and here the y is there, and you have to find the equation of wave. Find the equation of wave. Now two things are required. First thing is there, we will have to, for finding the equation of wave, we will have to do replace t by t minus x by v. This is the first step we have to find. And second step, we have to find phi naught is equals to how much. If we are able to find these two relations, these two values, we can certainly find the equation of wave. Now the question arises that this particle is at mean position. This is your mean position, x is equals to 0. But whether this particle is going up or down, that is the problem we are not understanding, because in the simple harmonic motion you have seen that here it is plus a, here it is minus a, then this we have understood that the particle is here. But if the particle is going in this direction, the phase, initial phase phi naught is 0, and if the particle is going in this direction, the initial phase phi naught is equals to pi. So the problem arises that this point is plus a in simple harmonic motion. In phase I have already discussed this thing, that how this is for pi and how this is 0, that you can see from there. So the question arises whether this particle is going towards plus a or minus a. That is the problem which we have to solve. If we are able to solve this problem, then we can easily find the equation of wave. So in order to find that situation, in order to get that relation, that whether the particle is going up or down, what I will tell you, you just try to proceed the wave in this direction, backward. And when you have produced the wave in backward direction, as the wave is going in this direction, so if we assume, right now the situation is at 0, but if we assume a very small time interval dt, then you will observe this wave will reach here, this will reach here, this will reach here, this will reach here, this will reach here, and so on. So if I take the situation, it will be going in this way. So what I have done, I have just shifted the wave in the direction of velocity. Actually the wave is here only, but I have assumed that after certain time, what will be the wave after a small interval of time dt. Then what we observe, that this particle has reached here. When this particle has reached here, its direction is towards what? Minus a. So this situation will be there. Particle is here, but its tendency is to go towards minus a. So initial phase will be phi naught, will be pi. So now the problem is solved. Now what we will do? We will write, therefore, equation of wave will be basically y is equals to a sine omega t minus x by v. T should be replaced by t minus x by v, and at the place of phi naught, what we will take? We will take pi plus pi. See? So this is the equation of wave. Now you simplify it and you will be getting this result. That means this equation will be a sine omega t minus kx plus pi, and sine pi plus theta is how much? Minus sine theta. So you can take minus as common also. So you will be getting a sine kx minus omega t. Kx minus this minus I have taken to this side, sine rate t minus theta. So this should be your equation of wave. The wave we have got. This is your first example. That the source is performing simple harmonic motion. The source is at mean position. Equation of motion of source is given by this relation. This is given, and this is also given that the wave is moving in positive x direction, and you have to find the equation of wave. So this should be the equation of wave. I hope that this will help you in clarifying the concept of wave. I will take further more example, and then I will try to explain the same situation. Suppose that in the same question I will be doing it in some different way. The source is performing the simple harmonic motion from, and this is the same question. This is the equation of particle performing simple harmonic motion at x is equals to 0. V is the velocity of wave. Wave is moving in this direction, and you have to find the equation of wave. Same question. Now in this situation, as I told you, that again we have to understand that whether this particle is moving up or down. This how can we decide? This we can decide, as I told you, first produce the wave in backward direction, then slightly shift the wave. Now you see, now in this situation, after certain particle is here only, but if we assume a situation after certain time, then this particle will reach here, and the direction of movement of particle is from x is equals to 0 to plus a. So in simple harmonic motion, here x is equals to 0, here it is plus a, here it is minus a. If the particle is moving towards this direction, naturally we get the phi naught is equals to 0, because the particle is moving. This you can understand from the phase lecture, in which I have mentioned that what is the value here. So here the phi naught is 0. Now the problem becomes simple. What is the problem? What is the question? Now the question becomes in this way. The equation of wave will be, this is the equation of SHM of this particle. So equation of wave will be y is equals to a sine omega t minus x by v, and plus phi naught is 0. So this is giving you y is equals to a sine omega t minus kx. This is the equation of wave. Again I am telling you, y is the function of x comma t. If you are finding that means y depends upon x also, and y depends upon t also. And what is y? Y is the displacement of particle performing simple harmonic motion during the wave motion. So this thing should be clearly understood to you people, that this is the way we slightly shift the wave in the direction. If it is moving in this direction, we will replace what? If the wave velocity I will change, then we will replace it by t plus x by v. In this direction, we have taken t minus x by v. If it is in this direction, we will take t plus x by v. Matter is simple. You can derive the relation. as the homework that 2 questions I have done with this direction of velocity, positive direction of velocity, and you will do the same 2 questions with negative direction of velocity, and that will enhance your concept further in a better way. So one more example I would like to take, that here we are getting the particle is at mean position, but is it essential that the particle will always be at mean position? It can be at any other position. It can be suppose from here. That also I will try to discuss. Let us try to understand. Take the third example. Suppose here the position of particle and this distance is a by 2, and here plus a minus a. Same question is there. Particle this time is here at the distance a by 2, at the distance a by 2 from origin. Now same question is there. Wave is moving in this direction. What will you do? What we can do? Equation will remain same, t minus x by v and phi naught. The problem is there that if we are able to phi naught, therefore I have discussed in the previous class how to calculate the phi naught, that is the initial phase. If we are able to calculate the value of phi naught here, we can easily write the equation. How? We will replace t by t minus x by v and we will put the value of phi naught. That's all. That will be giving you the equation of wave. So first of all, we will have to understand that this particle is going up or down. So for that, as I told you, we will proceed the wave into backward direction. We are proceeding the wave into backward direction. Then in the direction of wave, we will shift the position slowly. Assume that we are shifting the wave. So what we are getting? Now you see, this particle has the tendency to move towards this position. So this is the direction. That means it is towards plus a. So if we take the simple harmonic motion, here you take x is equals to 0. Here it is plus a. Here it is minus a. And the particle position is here, that is a by 2. And it is moving towards this direction, plus a. It is moving towards plus a. When it is moving towards plus a, what will be the phasor? We will have to find phi naught. So phi naught I will find, as I have discussed you in the last wave class. This is your plus a. This is your minus a. We are starting from here. Here it is a by 2. So 2 positions are there. 2 positions are there. Here x is equals to 0. This is a by 2. Sense of rotation is clockwise. So for a by 2 position, there are 2 values. One is this value and one is this value. But this is when it is going towards minus a and this is when it is going towards plus a. So this should be the value and this should be the answer of your phi naught. And what is this? This radius is basically a. So how do we find phi naught? This is phi naught, so this should be also phi naught. So for this we can take sine, this is also your phi naught, sine phi naught is equals to perpendicular a by 2 by hypotenuse a, that is sine phi naught is equals to 1 by 2, that is sine 30 degree. So phi naught is equals to 30 degree. 30 degree means pi by 6. So phase we have got. It is pi by 6. So what is our equation? Our equation of wave is y is equals to a sine omega t minus x by v plus phi naught is how much? Pi by 6. That's your answer. This is the equation of wave in which we have started our observation from this point. Similarly, we can move in this direction. Similarly, we can create a different type of situation. Sometime this will be a by 2, some more a by root 2 also we can take. We can take a by root 2 also. Sometime from this side we will start a by 2 and that will be a by root 2 or root 3 by 2a, whatever is the value. So in this way I hope that some understanding of the equation of wave, plane progressive harmonic wave, is with you and you have understood the concept of this, and you can, so I am giving you the homework. You will try to solve these questions and you will put into the comment box that whether you have been able in solving these questions or not. One time you will take, here you have taken a by 2. Next homework I am giving you, you take same position but a by root 2. You take same position but root 3 by 2a. You take in this side, here you take a by 2. Here, from here you start the wave in this way, and then root 3 a by 2. Then you take the position to be a by root 2. So these are the homework that I have given to you, and for every case you derive the equation. Everything will remain same, only this quantity will be changing. For different situation the equation will remain same, and provided the wave is moving in this direction. If the wave is moving in this direction, only at the place of this minus it will become plus. So as a homework I am giving you, create your question. Some creativity should be with the student. They should know the art of learning and know the art of solving the problem. Just copying the problem will not clarify the concept. Create the problem and solve by yourself, and if some difficulty is there, then consult and we will be solving it together. So my request is there, keep on practicing, and hope this much amount of discussion might have helped you in understanding the concept of equation of plane progressive harmonic wave in a better way, and it will be certainly useful for you if it will build your confidence if you understand the equation of plane progressive harmonic wave and its use at this deeper level. Thank you. Have a nice day.